Good morning, all. Welcome to our official YouTube channel of Hasum Goswami College of Engineering. I am Gautam Patel from Mathematics Department. Now, my topic is limit continuity and differentiability of complex functions of the subject complex variable and partial differential equation with its code is 313005. Now, first of all, we discuss what is a function of complex variables. So, complex variable we have need complex variables. So, z equal to x plus iy is a notation of the complex variable, where x is real part of the z, y is imaginary part of the z. Okay, then w equal to f of z equal to u plus ixy, which is a real part of the w, that means f of z, and plus iv of xy, which is where v is imaginary part of the w or f of z. Now u is depend on the x and y, v is depend on the also x and y. That means u and v both are very function variable of x and y. Okay, and this w equal to f of z is known as a complex function of complex variable z. Okay, next, main our first topic is limits. So for the limits, let w equal to f of z be a single valued function. Single value, that means in complex variables a function is multivariable function, but here our supposition, that means our assumption is a single value function. Then the limit of f of z is w0 this equal to f of z0, that means at point z0 as z approaches z0, if for each positive number epsilon, that means epsilon is the positive number. Okay, there exists a positive number delta, there exists a positive number delta such that modulus f of z minus w0, that means wz and f of z is distance is less than epsilon, whenever when modulus z minus z0, that means distance between z and z0 less than delta, if uh, this circle, that means interior circle of z0 center is less than with radius less than delta, then function f of z with center w0 with radius epsilon, okay, less than epsilon, right, which symbolically, that means this definite limit is represented as a symbolically limit z tends to z0 f of z this equal to w0, that means z0 approaches, sorry, z approaches z0, then f of z approaches w0. Okay, next is example, and this example by definition, that means definition of the limit, right? So question is here, using the definition of limits, show that if f of z equal to iz in the open disk mode z less than 1, then limit z tends to 1 f of z equal to I. Okay, so we have f of z equal to iz, where z0 is 1, w0 is I. Okay, so here z0 is 1 and w0 is I. Now let for epsilon greater than 0, here consider epsilon is positive, therefore mode of f of z minus w0 less than epsilon. Now put w0 and f of z, so iz minus I. Now I is common in both iz and I, so take outside, so with modulus, and with modulus mode I is 1, so mode of z minus 1 less than 1, we get mode z minus 1 less than epsilon. Not a 1, it's a epsilon. This condition is satisfied by the points in the open disk, because here given point set of points in open disk mod z less than 1. So assuming epsilon equal to delta, if we assuming epsilon equal to delta, then by definition for every epsilon greater than 0 there exists a delta greater than 0 such that mod of f of z minus I less than epsilon whenever mod z minus 1 less than delta. Hence, limit z tends to 1 f of z equal to I, which is our required solution. Right? Now, next example. This is not by definition, but here show that the limit z tends to 0, z upon z bar does not exist. That means here our question is showing that given limit is does not exist. Okay, so let f of z equal to z upon z bar with, we know that z is x plus iy. Always if you require variable z, that means complex variable z, then we take always x plus iy, substituting in the limit. So we get limit z tends to 0 f of z equal to limit z tends to 0 x plus iy upon here z bar. So we take x plus iy bar. So we know that x plus iy bar, that means it's a conjugate. So we change our sign uh, about the, not above but before the I complex part, that means imaginary part. So we get x minus iy. Now substituting z tends to 0, right? So necessary condition for limit z tends to 0 f of z to exist is that f of z should approaches the same value along the path leading to z equal to 0. Okay, so z tends to, for this limit apply path methods. Okay, that means there is a several variable methods. That means if you are given that more than one variable, then apply path, right? So hence limit z tends to 1 f of z equal to I, right? So sorry. So this let the path y equal to mx. So limit z tends to 0 x plus iy upon x minus iy, this equal to limit x tends to 0. Put here y is mx. So x plus imx, x minus imx. Now x is take common in numerator as well as denominator and cancel out. So we get 1 plus im, 1 minus im. This equal to 1 plus im upon 1 minus im. So we get for path y equal to mx, the limit depend on the value of m. That means is take different value along the different paths. That means if we take m different, then we get different path. So value of limit is also different. Hence the limit does not exist. So this type of problem we can apply path methods. Now continuity, right? Now this is the definition of continuity. The f of z is said to be continuous at z equal to z0 if limit z tends to z0 f of z exists. That means limit exists, and we know that if we put z0, then f of z0 both are equal, then function is continuous function, or f of z is continuous at z equal to z0, right? Next example of this continuous function. So determine whether f of z is continuous at z equal to y, and redefine if necessary to make it continuous. Okay, if function is not continuous, then redefine it becomes continuous. So first we determine whether function f of z is continuous or not. So here f of z is z square plus iz plus 2, where z not equal to y, and I when z equal to I. Now first we find the limit at z equal to I. So limit z tends to I f of z this equal to limit z tends to I, put z square plus iz plus 2 as a f of z. Now apply limit, so we get I square plus I into I square plus 2. Now we know that I square is minus 1, this I square is minus 1, minus 1 minus 1 minus 2, minus 2 plus 2 is 0. So this limit we get 0. Okay, but f of I is given that I, f of I is already given that I, so limit and function value both are different. Therefore f of z, therefore given f of z is not continuous. If it is not continuous, so your question is redefined. So we take here, if we take 0 here, I function at z equal to I is 0, then our function is continuous, right? Like this one. To make it continuous, it can be redefined. F of z is same, and f of z is 0 where z equal to I. For z equal to I, our f of z is 0. That means f of I is 0. Then our function is continuous, right? Now next, and very most important for the complex analysis, differentiability. Okay, so how to define differentiability in the complex? It's similarly as a real analysis. A single value function f of z is said to be differentiable at a point z0 if f dash z0, this equal to limit delta z tends to 0. Delta z, that means difference, like this one, difference between 2 points z and z0. F of z plus z0 plus delta z minus f of z0 upon delta z exists. If this is exists, this limit exists, that means this exists, then function f of z is differentiable at z0. Now derivative of f of z at z0 is can be written as f dash z0. This is equal to limit z tends to z0 f of z minus f of z0 upon z minus z0. How to evaluate this form? Put here delta z is z minus z0, so take z0 right hand side, f of z0, this is becomes z, and this as it is f of z0 and delta z, z minus z0. So this type of method we can find the different form, right? Now example. Okay, so what show that f of z, that means if statement is f of z equal to iz cube is differentiable for all z. So we can apply our definition of the differentiability. We have f of z is iz cube, right? It is given that. So for any z, f by the definition f dash z equal to limit delta z tends to 0 f of z plus delta z minus f of z upon delta z. Now putting f of z is iz cube, that means f of z plus delta z is I into z plus delta z whole raised to cube minus f of z is iz cube upon delta z. Now expand this z plus delta z cube. Okay, so we get z cube plus delta z cube plus 3z square into delta z plus 3z into delta z square minus iz cube upon delta z. Now uh, uh, okay, now look at that. Here this divide delta z in z cube, this iz cube minus iz cube, so iz cube minus iz cube cancel, right? Now in all terms delta z exists, so divide by delta z and then apply limit. So we apply limit, so we get 3iz square, which is the derivative of given f of z iz cube. Okay, therefore f dash z exists for all value of z, and this is for all value. No need for any substituting any particular value to find the derivative. Hence f of z is differentiable. Okay, so this is a differentiable example. Thank you for watching my video. Please share it, like it, and don't forget to subscribe it.